And we're off. First episode of the All Things Interesting podcast. And I have my first guest of the show here today, Kasian Franks. How are you?
Good. How are you?
I'm doing very well. Thank you for taking the time to join me today. We have a lot to talk about. I understand you have experience as a software engineer, also working in the fields of AI and machine learning within biosciences and life sciences, amongst other industries. You've also had 3 startups under your belt. So just to kick things off, there was an Economist article recently on the world's most valuable resource is no longer oil, but data. What does this mean to you, Kasian?
Well, I just think some of us are seeing an exponential explosion in data and are preparing for it by either developing new technologies or engaging in ways to manage this data and extract value from it. And because it's exponentially increasing, we're going to have some real issues in data management, but also refining that data, creating data sets, and then extracting knowledge and intelligence from those.
It's interesting you say that because there's a lot of articles that have been challenging what oil is relative to what data is. And a lot of opinionated articles came back on top of that one, mentioning that data isn't really the next oil for a variety of reasons, being that it's readily accessible, it's not tangible. But on the flip side, there seems to be a lot of reasoning to believe that data could be the new oil. For example, if we look at the value of it, an artificial intelligence, deep learning, machine learning aspect, there seems to be a great deal of potential for it when it comes to predictive analytics and creating new curated solutions to the world's greatest problems. Is that something you would agree with?
Yeah. I think that when you look at data as being analogous to a fossil fuel, that there's a lot of stored energy or stored knowledge in data. A lot of data starts as what looks like in an unstructured format. You'll see maybe something that might seem random. You'll see lots of data points that may not make sense, but there's hidden structure within data, and extracting that hidden structure starts with a refinement process where you're converting structured data into unstructured data, and you're maybe developing ways of extracting patterns and then being able to predict based on the patterns you observe in the data.
With that said, could we kind of turn back the clock here just to give people a better idea and understanding of who you are and your experiences, whether it be the work you've done or the companies you have started?
So my background is in software engineering. That's how I started. And that was a while ago. Started at Genentech, and I was asked to find patterns in manufacturing pharmaceutical data coming from the pharmaceutical pipelines. And there was it's a little bit like IoT data. We used PLC ladder logic controllers, and the data we extracted helped us to better build recipes and better understand how the entire process worked, drug development process. So I eventually graduated to working for companies in Silicon Valley like Oracle and Sun Microsystems. And some of the original tech companies, TiVo was another company I worked with. But I eventually moved into the bioinformatics area, and a lot of proof of concept or rapid application development was done there. The human genome had just been decoded in 2000, and there was a lot of data. And that data needed to be analyzed and interpreted, so that new discoveries could be made or new drug targets could be identified. And the kind of data that we focused on was gene expression data, but more specifically, we focused on human language surrounding genes, drugs, and diseases. Human language, the human language that we were analyzing came in the form of scientific abstracts. We mined the National Library of Medicine We brought in encyclopedias and dictionaries and ontologies, controlled vocabularies, and any other kind of data related to human language, text, that we could find to help us extract hidden relationships between genes, drugs, and diseases, and explain and interpret why maybe certain genes were interacting together. Now, eventually, the bioinformatics industry caved in, and companies weren't finding the billion-dollar drug targets that they had promised. We continued our work in natural language processing, basically, looking at language modeling and ways of extracting patterns from the language to make predictions. And we published some of our work. It was based on producing vectors of information. In a more technical term, these would be feature attributes. Vectors would have feature attributes with scores, and a vector might represent a gene. So a gene would have a list of scored attributes associated to it. Those scored attributes were learned as we processed text, and we began to publish these vectors, and it caught the attention of Lawrence Berkeley National Lab, who invited us there in 2002 to begin work on understanding the relationships between genes that were involved in extending lifespan and breast cancer genes and genes affected by LET radiation, which is a form of space radiation. So very interesting stuff. We didn't anticipate we were going to be working on that stuff, but we did. And eventually there was a patent assigned, and this enabled us to start a company around that patent. The company was called SeekPod, and we ran that company for about 4 years. And it attracted quite a bit of attention in terms of litigation. We had Apple and Warner and EMI attempt to sue us for up to $40 billion because we were a search engine. We were providing a way for consumers to find relationships between pieces of music, or between a podcast and another podcast, or a piece of music and a podcast. Anyway, we attracted the attention of, you might say, some of the old guard in the music industry, and we had to wind the company down. The main reason, though, we had to wind that company down was the economy was crashing in 2008, and everybody was battening down the hatches. Anyway, we decided to start a public company at that time called MIMV, and this was mobile apps. Search and discovery for mobile apps. We knew there were about 300 or 3,000 apps at the time, and we projected there would be a lot more. So we wanted to build a search and discovery experience around that using some of our data sets and technology and NLP. And we did pretty well. We raised a bit of funding. We got Microsoft to invest in us, and the rest was history. Brought in a new management team, and then I went my separate way and decided to look into cryptocurrency. That was about 2014. And started Songcoin with an investor from Australia and a couple of other partners. And Songcoin was supposed to be a cryptocurrency for the music industry to enable artists to exercise capital from the capital markets. Because if they had a crypto associated to themselves, they'd be able to raise capital, basically. We wanted to move this into a way for the public to invest in artists by eventually enabling every artist to have their own crypto and treating it like a music stock market where you can short, an artist you don't like, you can go long on one you do. You can have a basket of them and you can trade those and the artist gets capital and you get to exercise, an interesting kind of financial instrument and provide them with the capital while at the same time maybe seeing an increase in value in what you've decided to capitalize. So anyway, long story short on that one, the investor walked away because crypto was a little bit above his risk threshold, you might say. And that at the time, Mt. Gox had just been completely hacked, and that news had been reverberating, and our investor just decided to close up shop. So we had another guy, though, take our fork of Bitcoin and go ahead and list that on CoinMarketCap. That's just part of the nature of the Wild West, of the worldwide Wild West of cryptocurrency. Anyway, we took a little break as the crypto markets began to decline, mainly Bitcoin at the time, and reconfigured ourselves and figured we want to do something with data sets, which is something we've always worked with in the past. And we thought that the future, we thought about it, and the future really involves a lot of machines talking to one another and minimizing their loss. Because we're entering a world of data, just like you had started. We look at data as the new oil, and a way to refine that is with the machine learning process and getting machines to trade feature vectors with one another, minimize their loss. And we thought that involving a utility token would be a good way for machines to be incentivized, and the owners of the machines to be incentivized, the owners of the algorithms and the data, and a good way for machines to, almost in an auction-based system, be able to bid on feature vectors and use VXV, our utility token, to do so. So we kind of refined the process, and we entered the crypto markets with Vectorspace. We entered the crypto markets with a company called Starmine. But there again, we had one of our investors decide to take a break after the crypto markets had collapsed. So we quickly had to, again, adapt, pivot, and we started Vectorspace.ai. And that's where we offer data sets to the world. NLP, natural language processing, and NLU, natural language understanding data sets. And these are used to make predictions based on human language.
Now, it seems like vectors would be the central point in and around work that you have done in your past. Can we do a bit more exploration on the technologies involved, as well as the technical terms involved around vectors, and why they are so important when it comes to creating feature-rich data sets and utilizing them in terms of artificial intelligence and machine learning?
Sure. So vectors are a way to store information. If you look at the way that you can assemble attributes for something, for example, yourself, you have a favorite color, you have a favorite car, you have a favorite food, and you have a favorite location that you like to camp or something. You've got a lot of favorites, and you can consider those attributes. And they all have scores, because one is more important than the other in most cases. Now, if you took your vector with all those attributes, we could apply a simple distance calculation to understand who else is similar to you based on looking at your attributes and how they're scored in your vector, and looking at someone else's attributes and how they're scored in the vector. You two might both have a very high score for Lamborghini or something. You guys might have a very high score for chocolate chip cookies as your favorite food. And so you can see that when you add those scores up and do a few other mathematical operations, you can come up with a similarity measurement that will tell someone how similar you are to that person over there who also likes chocolate chip cookies. So vectors are important for the way that we store information cognitively. If you look at a vector, if you look at a labeled or a keyed vector, This would just be the same thing I described to you. You know, you've got chocolate chip cookie with a score of 100, and then you've got Lambo with a score of 50. Or your next favorite thing might be apples, you know, and they have a score of 40. So when you look at a labeled vector or a key vector like that, it contains the same structure, a very similar structure to the way your neurons, synapses connect, your neural connections. When you look at a set of vectors, that's what you call a vector space. And within that set of vectors is a graph network, a network of nodes and edges that represent almost like a graphical model, you might say, or a tree. And being able to encode information like that in a vector, we've found to be the most effective way to extract hidden relationships or detect hidden relationships between things. And that's why we started with vectors in 2000 when we were in the bioinformatics area there.
So let me ask you this. It seems like vectors are integral in developing out relations between different elements, whether it be people, music, food, whatever you can name. But at the same time, if we look at data as a whole, there is data that we have to sort through that is uncategorized. Now, one of the challenges I can foresee is how are relations really looked at when there's context involved?
Yeah, well, we have a few proprietary techniques we use, and we've got a few techniques that I'm sure others use related to filtering, with applying filters, using vectors as filters. So if I asked you what you thought of when you thought of the word car, what would you tell me?
Off the bat, I'd probably say tire.
Okay. But now if I asked what do you think of when you think of the word car in the context of cushions?
Seat.
Right. So context can absolutely guide the discovery process, or the process of generating a new hypothesis or insight or interpretation. It's all how you look at it. The word cleave has a definition that has two definitions, and they both mean the opposite of one another. The context is it's important, and sometimes not using it is important. We find that you have to have it as an option. You can't operate without context, without the option of having context control or control over your context. So because it affects the outcome drastically.
Right. And that seems like one of the major issues when it comes to sorting through data and manipulating it in a fashion that will bring about an optimal output. You have the idea of feature engineering, which, for those who don't know, is the idea of turning raw data into fuel, so to speak. Now, it takes a lot of manual work to do feature engineering and to pull data and refine it. What do you think are challenges currently being faced within the industry to manage raw data, whether it be categorized or uncategorized, outside of general feature engineering topics or anything related to loss function and context control? Do you think there are other challenges that are pervasive within the industry currently?
Well, yeah. Real-time data collection and the storage for that. For example, if we wanted to mimic portions of human cognition related to the senses, we would want to be taking in as many frames as an eyeball takes in, or as many audio frames as an ear takes in. And we don't have the capacity today to store that kind of data, let alone extract features from it on the fly in that capacity. So that's a challenge. How we're going to get around that, could be based on molecular computing, quantum computing, DNA computing, a combination of them all. We'll see.
And it's funny you say that because there was a recent article that I read that kind of drawed upon the idea that Elon Musk, Bill Gates, and Stephen Hawking had the idea that AI poses a lot of potential dangers in the next 10 to 20 years, more or less around the idea that artificial intelligence could become sentient or that they could outsmart humans. I mean, you have technologies, I believe it's called AlphaGo, which utilizes deep learning and Monte Carlo trees to basically teach itself to play certain games, whether they be Alpha, chess, or StarCraft 2, amongst others. And they have taught themselves so well that they beat the top players in the world. Now, again, this is on a smaller scale and not really on the level of human biology, but based on your comments, do you agree that AI doesn't necessarily pose a strong threat to civilization in the foreseeable future? Is just because there is a lot of detail that AI does not understand, or that even humans don't understand, like you mentioned about the eyes?
Well, I would say that I would paraphrase from and someone who actually knows something about artificial intelligence, because let me just paraphrase what Michael I. Jordan said related to, and he's a machine learning extraordinaire expert. You should look him up. But in one of his talks, he said that when Elon Musk and Stephen Hawking had said that AI is a big threat, he said that they are not artificial intelligence engineers. They're not machine learning experts. And they don't know what they're talking about. Now, this is coming from leaders in the field of artificial intelligence and machine learning. Now, does that make that makes perfect sense to me, and I'm sure it makes sense to you. So anyone that comments on AI being some global threat or threat to humanity should have spent a few years building AI algorithms themselves.
I'm assuming because the complexity is unparalleled to some of the technologies that we've dealt with in the past. They could just imagine that when you look at artificial intelligence, if we relate it to human beings, there's so much, like I've said, we don't know about ourselves. Of course, we've mapped the human genome, but that is only a small portion of a larger picture when it comes to developing out computer-based intelligence to operate in a similar functionality as a human being. It doesn't seem to be feasible, at least in the short to near future, to be quite frank. But it causes a lot of noise to the general public when they see, for example, Tesla utilizing self-driving cars that causes accidents. You see all these issues occurring, and it brings to question what are the challenges that we're going to face in the near future when it comes to developing out artificial intelligence, automation, and
so yeah, I think your point about achieving artificial general intelligence or getting machines to think similar to the way a human might, I think you're right. We have trouble defining intelligence ourselves, and until we can understand what human intellect really is, and how to use it properly, I don't think that we're going to get anywhere near getting machines to be as intelligent as humans. Machine intelligence might be something we could have never predicted. It might be something completely unfamiliar. it might be something entirely different than human intelligence.
But if we look at more near future, there is a professor by the name of Richard Baldwin who coined a phrase called globotics. And I'm not sure what your familiarity is with globotics, but the idea behind it would be a combination between AI and robotics. And what this supposedly will lead to is automation within the workforce with an end result of loss in jobs. What are your thoughts on that?
Well, I don't know much about globotics, but I've been reading a little bit about it. And it makes sense, a little bit of it. I don't really think I have enough knowledge to comment on it in depth, but I do think that, we are headed into a world where we've got lots of machines that are going to be talking to one another. And these machines are going to take on jobs that humans otherwise would be able to do, or were doing. From any time a human uses their eye to recognize something, anytime a human uses their ear to translate text, we can get machines to do those kinds of things, a lot of those kinds of things. The interpretation of text is a bit different. We can't get machines to do that yet, just like we can't get machines to produce poetry or tell a joke or create and solve a riddle,
So why don't you think computers are able to tell jokes, for example? I think it kind of goes back to natural language understanding, and correct me if I'm wrong on that, but wouldn't that kind of revolve around the idea that computers are not able to fully understand language in the way that humans are able to understand language and to create their own outputs from it?
Yeah, we don't understand how the human brain processes language completely. So it would be impossible for us to get a machine to process language similar to the way...
Or to mimic the same thing. So in a sense, creativity is kind of a niche that's carved out that is not necessarily going to be impacted within any industry. But if we look at what jobs may be impacted by automation, we're looking at basically admin jobs. Anything that requires someone to manage basic intake forms of data or information, or retail, for example, when you're handling minimal transactions. Is that something you would kind of agree with in terms of jobs that are impacted in the near future?
And it's going to be up to the individual to learn how to type and learn how to adapt to a really new technological world we're entering, where, if you don't understand how the machines are working, you're going to have a bad time.
And just to kind of piggyback on that, I also recently heard a conversation with Andrew Yang, who is a candidate for presidency, and he was on the Joe Rogan podcast talking about universal basic income. And his thoughts on it are that the technologies that we see emerging today are going to result in massive job loss, mainly in retail, service industry, trucking, for example, and that we're going to need to rely on universal basic income, or a $1,000 for a month stipend for the general public, irrespective of how much money you make per year. And it seems kind of drastic, but on the opposite end of that, there's also a very well-renowned investor and tech entrepreneur by the name of Naval Ravikant, who has a completely opposite opinion on the matter, in that basically technology is always going to change, and we're going to consistently see an evolution of the jobs that are currently available. So if we look at the Industrial Revolution, of course, we lost jobs due to industrialization, having automation through industrial lines, anything of that nature. But in a sense, it created new jobs. Now, if we look at it in today's day and age, of course, we may lose tons of jobs to automation, but do you think that it's going to create newer jobs, whether it be in data or otherwise, that's going to still maintain job security for many individuals out there who kind of fear the idea that automation is going to take their jobs away and that universal basic income is not going to be sustainable for them.
Well, yeah, I do have comments on that. First off, it's a political lightning rod, the universal basic income issue. I don't have many opinions on it. I think that anything you can do to keep people from starving to death, of course you want to do that, and you want to enable people to get back up on their feet and be productive, to create something, do something. I think there's going to have to be something that's done in the form of educating the public that's going to maybe be affected by losing their jobs to automation. Part of what can be done, to me, relates to just educating people on how technology works, how software works, how machines work. And once you do that, once it's no longer magic to them, then people might be able to go in and understand where they can start making an impact of some kind, an impact into their own personal career trajectories. The one thing that I'm noticing as a technologist and in talking with others in my line of work is that there are more and more people that are, I guess, surfacing or coming on the internet, just not knowing how technology works. And to them, it's like black magic or something, and they just move on. A lot of our world is driven by software, and to not understand that is to be left out.
It's interesting you say that, because if we look at the world 20 or 30 years ago, some of the technologies we had back in the 90s is far different from what we have now. So if we look at capabilities between the past 30 years and now, you'll see a lot's happened. You'll see a lot of technologies have emerged, and it seems very difficult to keep up to the pace of how much we are changing at. So we have to bring the question, how is it that are people going to be able to keep up with the times and continue to learn, or if they haven't started learning, to begin learning about all these technologies? Do you have any advice that you would give any individual who is basically starting at a baseline level?
Yeah, learn how to type. And you'd be surprised, but people underestimate the ability to interface with a piece of software. And you don't interface with a piece of software by touching one key and waiting 1 second and finding another key and waiting another second. You have to be able to communicate with the machine. And it doesn't happen with your thumbs on your phone. It happens only with a keyboard. That's how you cut code. And there's no way around it. That takes work. It takes work to be able to then understand what you need to communicate to a piece of software, to construct something, to build something, to understand how something works, to fix something, to build your career based on fixing something related to a piece of software.
Now let me ask you this. Coding seems to be a very prized and sought after degree these days. Most people are encouraging those around them to go into programming, become a developer, not only because there's not enough individuals in the industry, but because it seems to be the direction society is going when it comes to encouraging the development of new technologies. But for individuals who don't know much about programming, what would you compare programming to on a basic level? So, for example, if someone wants to go into programming and they struggle at mathematics, is that a direct comparison, or would you say programming is not on the same level of complexity as mathematics? Is it just telling a computer what to do and giving it basic instruction, or is there some other methodology to it?
Well, let's look at it this way. There's software notation, and there's mathematical notation, there's music notation, there's poetry, there's learning different kinds of human languages, there's learning how to do brain surgery, there's learning how to do heart surgery, or be a foot doctor. So when you learn a group of symbols and how to organize them in ways so that they produce, or you can create something with them, that's what you're doing when you're developing software. When you're writing a piece of software code, it's like writing in a different language sometimes. You, for example, could be a C coder and you know nothing about JavaScript. You could be a Java coder, know nothing about Python. So if you treat it like learning maybe Russian and then doing Russian poetry if you don't speak Russian, that might be like that, or Japanese and doing Japanese poetry. It takes work, like most things and most valuable things, right? It takes an investment of time, and you have to put in the hard work in order to accomplish something.
So it seems as if there's some creative aspects to programming when compared to things like poetry and whatnot, but it seems to be a very, very sought after skill that most people should definitely look into if they are trying to keep up with the times, so to speak, and to kind of immerse themselves in emerging technologies and areas that are becoming more valuable to them. But nonetheless, it's a very interesting topic to deep dive into. But just to kind of go on a quick tangent here, I want to go back and talk about some of the innovation done within other countries. One thing specifically would be gene therapy. Now, there is a lot of research being done by many other countries on genetic modification and lab-based in vitro. So for those that don't know, the idea behind this is to genetically modify the child prior to birth so that parents are able to create their own children. Now, this is a very new technology, but it's becoming more and more popular these days. What are your thoughts on that, and what are your thoughts on artificial intelligence and machine learning having a direct impact on it?
Oh, well, I can only speak from the vantage of having worked with language surrounding human genes and diseases and therapeutics. And from that perspective, understanding the impact of a gene therapy, or understanding the impact of how a gene might be turned on or off, understanding how that might connect to particular pathways. We can analyze human language to get a better understanding of interactions between genes or proteins or other kinds of metabolic pathways, or your microbiome. So based on what we've done in the past, which is extract patterns from human language, understanding new insights into the impact of modifying your genome. We can help in that area based on what we do, but that's about all that I can say related to that area, because we don't know too much about CRISPR and other kinds of gene therapies. But I do know that when the human genome was first decoded, there were people thinking about how to modify the genome, so maybe to have a better impact in terms of childbirth, life expectancy, things like that.
So one interesting thing you pointed out was understanding the relations between certain genes. Now, if we look at it in the context of vectors, It seems as though there's a lot of potential in the life sciences or biosciences, correction, to basically determine relations between certain ailments or possibly certain cures to develop out more innovative, basically medicines for these ailments. Is this something you see being more prevalent in the near future and resulting in a greater reduction in certain ailments that are plaguing society these days?
Well, the closest that we've gotten into understanding relationships between diseases and maybe the environment was based on analyzing the online Mendelian inheritance in man. It's a disease database that you'll find at the National Library of Medicine. It's associated to the Medline, I think it is. But looking at diseases and how they're correlated to genes or proteins or microbes in scientific literature is absolutely a gold mine. And we've always wanted to do a little more work in that area. Right now we're looking at LET radiation, space radiation, and its effect on chromosomes. We're looking at ways to affect the repair of DNA a little bit better. And we're looking at a lot of scientific literature to be able to do that, applying natural language processing, natural language understanding, to be able to extract these relationships. And your environment has a lot to do with the way a disease might progress sometimes. So the microbiome also has a lot. We're discovering these days, recently, how much of an impact microbes have on your immune system and even the expression of your DNA. So we definitely would like to put some work into maybe understanding how phytochemicals or botanicals, micronutrients, plant compounds, other environmental factors correlate in the scientific literature to certain diseases. And then in what context? Because then we can either develop new hypotheses or get a new insight, gain a new insight, or even make a discovery. Take two pieces of knowledge and combine them to come up with something new based on looking at data and looking at the data set that results from that data, and then the resulting machine learning operations on top of that data set that help extract hidden relationships between diseases and environmental factors.
What do you think are the most promising possible advancements within the industry of biosciences utilizing artificial intelligence and vectors? Is there anything based off of your experience in the past work, post genome mapping, that has the greatest potential, even outside of biosciences?
Well, there was just yesterday a paper published in Nature related to unsupervised learning approaches. And this is when you have non-labeled data, unstructured data basically, and you're creating features for it. But the paper described a way of using word embeddings, vectors, to extract new relationships in the material sciences based on analyzing scientific literature in the material sciences. That was very interesting to see, because when you look outside of life sciences or biosciences, the applications are everywhere. Applications for machine learning and AI operations. They're anywhere that you find data. Anywhere that you find data, you can create a data set. And anywhere you have a data set, you can run a machine learning operation over it. And just to clarify, when you say AI and vectors, well, looking and comparing vectors for similarity, maybe an input vector to an output vector, running a distance calculation on it and comparing it for similarity so you can adjust the loss in the overall machine learning operation. That operation right there, comparing vectors with one another, is a central operation in machine learning and AI. So when you look at the way machine learning and AI apply to just about every industry, yeah, you can see that, applying vectors and being being able to create vectors in ways that fit a little better to the domain that you're operating in. That's where I think that's where the real value is, in understanding how you score those attributes within these vectors. And then, choosing your distance calculation. That's also pretty important. It's going to affect your overall loss or performance in the end, accuracy. So, yeah, the way we look at it is there are breakthroughs that are going to be made because in any industry, because there are hidden relationships in every industry. In every category of data, there are hidden relationships. There are hidden structures within data that can be extracted. And it's endless. So that's the world we live in today, is understanding how to process information similar to the way a human might do so. Engaging in a little bit of biomimicry and mimicking a portion of human cognition. And it just so happens today that, we do that with machine learning and AI operations. And at its core, comparing vectors with one another. So, just to reiterate, how those vectors are constructed really matters. How you construct your vectors. And there are lots of different ways to do that. We have our own unique proprietary ways. We have ways we use that are part of public domain. But it's the combination or the ensemble that matters in the end. Once you've got really good ways of calculating scores for attributes, then you're looking at maybe using state-of-the-art models and their vectors and combining them, pooling them, understanding which ones work in which domains. So, as we refine this whole process of machine learning and really hone in on verticals of information, verticals of data, it's just going to get better and we'll make more discoveries.
So it's a lot of exciting stuff if we look at that. It seems as if there's going to be exponential growth in the near future. Of course, there's a lot of fear of where we're going because we don't have the technology readily available to face some of the world's greatest challenges. But there seems to be a lot of optimism around this, at the very least, that if we truly deep dive into vectors and the ability to create such relations, that we may be able to find solutions to some of the world's greatest problems. And that's not to say it's going to happen overnight. There's a lot of data to sort through. There's a lot of work to be done with machine learning and artificial intelligence on many different fronts. But nonetheless, it's very, very fascinating to discuss these topics and to understand their widespread potential that they have on society. But with that said, I kind of want to segue into a key topic, and that is blockchain technology and the work that you and your company are currently working on in that industry. But before we go into what Vectorspace AI is, can you give a little bit of background for those who don't know? What is blockchain technology? What is cryptocurrency? And to kind of alleviate some of the misconception there is, so to speak, with this main connotation of blockchain technology being Bitcoin and nothing else.
So, yeah, you absolutely have to separate the world of blockchain from the world of cryptocurrency. They obviously intersect, they're related. But we utilize blockchain as a way to control data lineage or data provenance. It makes a lot of sense. You hash your data, you have it in an immutable state so it doesn't change, and you can track every aspect of it, or every aspect you define. Now, data provenance is very important it's a very important part of data engineering, data science, machine learning, AI, especially with financial institutions. You want to know where your data is coming from. In the sciences, you absolutely want to know that it's valid, it's correct, and it is what it says it is. So utilizing blockchain to manage data lineage makes perfect sense for us because we deal in data sets. We make data sets. We produce correlation matrix data sets. For example, public companies buy drug compounds. And just in case anyone doesn't know what a data set is, you can look at it as maybe an Excel spreadsheet where you've got rows and columns. And the rows and columns that we have in our data sets represent correlation scores between two things, like a pharmaceutical company and a drug compound, or another public company and one of the elements in the periodic table of elements, or a chemical and another public company, or a gene and a drug compound. When you look at data sets like that, correlation matrix data sets, you can cluster. That means you can group things that relate to one another. You can separate them into groups and make different observations. You can understand why relationships exist between objects in the group, or entities in the group, or equities, stocks, or genes, or pieces of music, movies. So the kinds of data sets that we currently build are mainly for the financial industry and the life sciences space. One of the reasons for that is we are currently on the verge of generating revenue by enabling other funds and institutions with these data sets so that they can run their own machine learning operations on them and maybe extract a new signal or increase their alpha, which is a simple way of saying how they make money. So we intend to move into the life sciences industry maybe in about a year, but right now we are going to focus on providing data sets to hedge funds, asset management companies, and other institutions that want to find hidden relationships between public companies and outside events or trends or topics or customized categories, and based on the context. And we also have those data sets updating every minute. So, as you can imagine, running a data source that changes and then intercepting the changes and having them reflected in a new updated data set, that's pretty important to people that have billions on the line, and that's what we've made available to them.
The word that stuck out for me was data provenance, which is data lineage plus all of the inputs, systems, and processes that are associated with them. Now, what would you say the necessity for Vectorspace AI is within the blockchain industry?
Well, the necessity for Vectorspace AI is the data lineage or the data provenance part. It's a form of tracking, right? So that's why we use the blockchain. You can track data. So if data comes in, maybe you want to know what time it came in. Maybe you want to know what pieces of software touched that data and at what location, or how much data was involved and how it changed over a particular time period. You want to hash that. Next, you want to hash where the data was transferred and processed and who processed it. What parameters were used. You hash that. There are so many different things that you can hash about the way data gets transformed over a data engineering pipeline that every piece of data will have its unique record, and you can go back and you can see how that data was changed and when and why, and that's the immutable part of it, is looking at how data changes over time, but not being able to change it yourself, go back in history, and change something about the data, because data provenance has a lot to do with security as well. And one way to fool a machine learning algorithm or an AI algorithm is to be able to manipulate the data set. So that's why data provenance is very important, data lineage.
I understand that data provenance is important in securing the fundamental data. There's a vector pool each change in that data.
Well, that's separate. So the way vectors are built is separate from data provenance. The detailed process of the way that it's built. So we don't track every change and every zero in one. We'll track that on a more broad-based approach. So, but yeah, feature vectors. If a machine trades a feature vector with one another, there's data provenance associated to it.
So what are some of the key areas that Vectorspace AI is focusing on now and plans to in the future? Because there seems to be a lot of potential in and around comparing various vectors, whether it be in life sciences with financial data amongst different companies, or biosciences when you're looking at key drugs for reducing the occurrences of certain diseases, amongst other things.
Well, what we're working on today is providing data sets to funds and institutions, asset managers, hedge funds. So that's what we're focusing on. And the kind of customers that we have, they're all going to be in the financial markets. And financial markets includes the crypto markets. So providing data sets that produce baskets of related cryptocurrencies or baskets of related stocks, and then being able to trade those baskets. Those are the kinds of things that we're focused on today. And we're going to announce ourselves to the world. Well, actually, Elastic. This is a company this is the world's largest open source enterprise search company, publicly traded as well. They're going to announce us in terms of what we're doing with their Canvas product, which is a visualization product related to being able to visualize the relationships in our data sets. So we're kind of being showcased, and we're happy about that because Elastic is a very nice company. We've known about them since inception, because we've been in the search industry for quite some time ourselves and know quite a bit about it.
So what does Elastic do for those who don't know? It's I've done some research on them in the past, and their customer base is quite massive. I understand they operate in the enterprise search industry, but what does that exactly entail?
Well, I can tell you that it involves processing data and extracting patterns from data, visualizing data, management of data. So in a general sense, that's what Elastic does. Log data from search indices, crawled data, any data that you crawl on the internet. They have a pretty nice way of being able to index the data, ingest it, and then enable you to manipulate that data, view it in different ways. And that's why we're working with them, because we deal in data sets, and being able to manipulate our data sets and place them inside search indices and other kinds of analytics is pretty important to us. And then being able to visualize and gain new insights, that's important to our customers. So it's great for us, because if you're a company that provides services like Elastic, every company needs you. And you're analyzing the data that they produce. You're helping them analyze the data they produce. So now you can help, individuals, but when you're helping enterprises, you've got, most of the large companies around the world needing services related to analyzing their data. And those are Elastic's customers. So, we'll probably garner a bit of interest from their customer base based on what we're offering.
What kind of potential growth opportunities or what potential outcomes does Elastic and Vectorspace AI see forming from the partnership?
So, yeah, Elastic, you mentioned they have a pretty big customer base. So having them essentially vet us and say, hey, everybody check out Vectorspace. Having them say that to their customer base, that's a pretty strong endorsement. So we're pretty happy about that. Being able to introduce their customer base to our platform and some of the products we're offering, we can't really predict what kind of growth curve that's going to result in, but we know it's positive, very positive. So, yeah, we're ecstatic about that.
When we look at the possible applications of vector space within Elastic, how can we see some of the data be leveraged once the data sets are inputted into Elastic's canvas? What kind of outcomes or applications do you foresee with it?
Well, what the article is about, that I think we'll have published maybe in a couple of weeks, hopefully sooner. The article describes a way to use the data sets to generate alpha or improve your signal. And that connects to a back test that we perform with the data sets. The data sets are used, like I mentioned before, to produce clusters, in this case, baskets of related stocks. And we're showing that based on an event, you can retrieve a cluster of stocks related to that event, and you can watch them move. You can look at them move in sympathy with the event, maybe up or down, short or long, and you can profit. And so this is what we show in the article. We show that you can use the Elastic Cloud, the on-premise enterprise solution they have. They call it the Elastic Enterprise Cloud. You can use that to analyze your data sets and then visualize using Canvas, which is part of the Elastic Enterprise Cloud. Obviously, it's part of the Elk stack, as they call it. And you can achieve alpha by modifying parameters and plugging in new data sets, controlling the context in different ways, and then being able to see returns over time, being able to see the Sharpe ratio or Sortino ratio change over time. And, we kind of want to be able to show how you can benefit practically using a form of machine learning to achieve a better, let's say, return on your investment. So we're looking at, what we've noticed is that a lot of customers, they want the privacy. So they want the on-premise solution. So when we take the on-premise cloud solution of Elastics and we add our data sets and then we combine the Canvas visualization, it's a pretty good way for, let's say, a low-tier fund, small fund just starting out, to get involved with machine learning. So that's what we're prepared to offer the world when this Elastic article goes out. And it's a multi-part article. This is just part one. Part two, we're going to talk about some other interesting things related to combining state-of-the-art models. And we're also going to talk about looking at the different ways you can compare vectors with one another and how that affects the Sortino ratio or the Sharpe ratio, which is a way of measuring risk of your backtest or risk of your return. So we're also looking at Elastic bundling our data sets with some of their products. And then, of course, that would involve revenue sharing and a bunch of other stuff like that. But, it's early days. We're going to take it one day at a time, and we're going to grow our relationship with Elastic and other companies that, have identified value at Vectorspace.
So it seems like there's a lot of potential within that partnership itself. One of the interesting aspects of it that you mentioned to me was the potential to find patterns between different companies to ensure that you're finding alpha, to ensure that you kind of have the edge when it comes to investing, so that you have the greatest return on your investments when competing with these hedge funds. Now, one of the bigger challenges I can kind of foresee coming out of this when looking at an investment point of view is there are going to be a lot of companies out there that are investing in the technology to give them the edge when it comes to finding relations between certain stocks or certain cryptos so they can achieve higher return on investments. Are there any concerns from your perspective that may arise when there's hundreds of hedge funds competing to find alpha utilizing machine learning methods or artificial intelligence based methods, whether they be vectors or otherwise?
Well, if everybody's using the same algorithm or the same data sets, it's not going to work out for anybody. In order to maintain an edge, you have to be doing something unique and something that most other groups aren't doing. And one way to do that is to access a unique data set. So the combinations of data sets that you can create at Vectorspace, it's in the billions. If you think about what category your rows can be, sectors of equities, sectors of stocks, sectors of cryptocurrencies, categories. And if you look at your columns, you might think that, well, these guys offer drug compounds as the columns, or genes, and that's it. Well, no, you can actually customize these columns to be anything that you want. You can have pharmaceutical companies buy chocolate chip cookies, or, cars buy flowers. So you can establish relationships between anything that you'd like, as long as the data sources are available. And we've got data sources for a lot of different kinds of things. And that means the kinds of data set combinations or permutations are very numerous. So you can, as a fund or an asset management company, you can create a data set of Vectorspace, and it can be something unique to you. So that's one way we enable, let's say, or prevent the decay experienced with using, an algorithm or a data set, the same data set over time. Our data sets also update. So when new information comes in, you can receive a new correlation value. For example, if you have pharmaceutical companies for the rows, and you've got drug compounds for the columns, there might be a static correlation involved until you start bringing in, let's say, 1,500 newly published scientific papers from the National Library of Medicine every 24 hours. Then you'll begin to notice those correlations change, and likely, because of updated correlations, you'll have more value. If you add news, then you've got another dimension of data that has an effect on the correlation scores. So obviously, if a pharmaceutical company had a relationship with a drug compound and there was news out on that drug compound, maybe it was bad news, you can expect that pharmaceutical company to drop. You might also expect related pharmaceutical companies to drop because they might have similar drugs in their pipeline or something. So these are the kinds of things you can do. It's kind of a form of asymmetric information or information arbitrage you can engage in here. If you're finding patterns before anyone else, then you're staying ahead of the game, and that's your edge.
So this is, in essence, the advantage that utilizing Vectorspace AI gives a company, whether they be a hedge fund or a tech company, when it comes to have the most advantageous decision making when it comes to strategy or investments, amongst other things. So it's pretty fascinating to see what is possible with Vectorspace AI in the industry, or various industries for that matter. So with that said, it seems as if there's a great deal of potential with this partnership.
Yeah, definitely. I mean, it's going to help. It's really, it's an introduction to the world, an endorsement, and we're really happy to be able to work with Elastic. But we've got other customers, we've got other partners, and we need to pay attention to. But we're going to, we're still a small team, right? So we're going to, use our resources wisely, devote our resources wisely, you might say, because we really want to be able to make sure we are, let's say, meeting our revenue targets, because we have internal revenue projections based on what we see we can do with this technology and with the addressable market. And we look at the financial markets as a perfect place for us because we've got a lot of experience ourselves in the financial markets. and on both sides, running public companies and moving money around in the markets and working for, advising a couple of hedge funds. So we look at servicing the financial markets as, of course, a way to generate revenue, and that's going to enable us to raise maybe a little more capital in the future, and maybe put some funding into our life sciences efforts, our space biosciences efforts.
And one interesting thing that stood out when we mentioned the possible exposure that comes with a partnership like this is just to see the amount of companies that are beginning to not only invest in blockchain technology, but to kind of immerse themselves with developments of their own products. Whether you look at companies like JP Morgan, who is creating the JP coin, or even Facebook with the Libra coin, you see a lot of companies beginning to invest into the technology, and it's creating a lot of circulation and exposure to the industry itself, and it's bringing in a lot of people, whether they be investors, hobbyists, and the like. And it's fascinating to see the potential that blockchain cryptocurrency have. So just to see a partnership like Elastic come to fruition, it's not only great exposure for the Vectorspace AI, but it's also very, very good for the industry as a whole.
Yeah. It's a way for us to prove our model, and in that model, our customers using our utility token, VXV, to exchange data sets, create data sets, get updated data sets.
Now, I'm not sure how many people out there are really familiar with what a utility token is. Can you kind of give a bit of background on that in relation to cryptocurrency?
Sure. Utility token is usually used to access a service or invoke some operation within a machine, or transact a piece of information or data, or access a tiered level of service from some platform. For us, it's accessing tiered service levels of Vectorspace AI datasets, and different kinds of context controls, for example, different data sources, different updating schemes. So we require every customer to fill a wallet with VXV. That's the name of our utility token. And after that, based on what service level they've chosen, they get access to that tier based on an API that uses their wallet address hashed to another API key. So we do a check on their wallet to see if they have enough VXV in their wallet, and if they do, they're good to go. If they don't, then we send them a message and let them know they need more VXV in their wallet to access data sets. So in our onboarding process, we allow for fiat subscriptions, standard, the standard way people like to pay. People don't like to pay in cryptocurrency for lots of different reasons. And they think it's, they think it's going to go up in value, which it is, and they also, just find it a pain in the butt to have to transact in crypto sometimes. So, and this is with people that, don't usually or have never transacted in crypto. A lot of our customers, one of our customers didn't know who Binance was. Binance is, the world's most popular cryptocurrency exchange. Some of our customers thought that you had to buy one Bitcoin, and these are financial institutions, one whole Bitcoin in order to own a Bitcoin. And these are kind of old guard financial institutions that have not given too much attention to crypto because maybe they don't understand it, or the way to use crypto or trade it has too much friction. In any case, we're going to make it easy. We're going to remove the friction, and we're going to create a frictionless experience for our customers. So they're able to use fiat, and then we transact that to BTC ETH, and then we execute an automated buy order on IDEX. And then a wallet gets filled and gets passed back to them, and they're able to use the service by passing that as an API key. And that's why we call it the VXV wallet-enabled API.
So it's funny you mention all of that because I've been following cryptocurrency and blockchain technology since around 2011 or so. And when I first started looking at it, I was very put off by how complex it was to really navigate these exchanges and to move around currencies. And it's something I never really took upon myself until around 2017 or so, when we kind of saw the markets rapidly rise out of nowhere near, I think, October or November. But nonetheless, it really put off most people from investing outside of exchanges such as Coinbase because of the idea of transacting between wallets via addresses and the fear of losing your currency, things of that nature. And it still seems to be one of the greatest challenges in the industry to bring about adoption. People aren't really comfortable with the idea of investing or researching or to really exposing themselves to the technology because it's not as user friendly as old guard, like you said, based technologies or businesses. So what do you think, in your opinion, are some ways to spur an adoption or to create a more accessible environment for newcomers to enter the industry, or to kind of give themselves a greater abundance of knowledge within blockchain?
Well, it's probably what Fidelity is doing now, making it available, making crypto trading and asset holding available. Fidelity is, I think they have $6 trillion under management now. One of the biggest funds, one of the biggest asset managers and financial institutions as a whole out there. JP Morgan is making it easy for their clients with JP Coin and a few other things they're doing. We're actually talking with one of their cryptocurrency guys there. We'll see if we can work something out with them. I'm not sure yet. But the onboarding experience, if you've never used crypto before, you're going to find that it's tough. And one of the reasons for that is security. And I think when people begin to understand the importance of keeping their software secure, that's when they'll have the energy to go through a few hoops to transact crypto for the first time. Security it's pretty much non-existent with a lot of people, and I think that hinders people from adoption when they know themselves that they're not secure in the way they operate on the internet or operate with software or share information with friends. You have to have a secure environment when it comes to crypto, because if you don't, you're going to get robbed. I had a neighbor who wanted to get into crypto and wanted me to tell them something about crypto. And so I sent them a little ETH, sent them a little VXV, and showed them how to make a wallet. And as I had them bring their laptop over, and it was like a 10-year-old Mac. And when they opened it up, they were putting their password into my Ether wallet. And as they were putting their password in, there was a little green dinosaur that was following every keystroke. And I said, "What is that green dinosaur doing following every keystroke?" And they said, "Well, it helps me remember my passwords." I went, "Oh my God. That's a keylogger." They had so much malware on their machines, it was insane. Or that guy did. And the concept of security is non-existent, and when it is, it doesn't make any sense for people to get into crypto. So if you can provide a secure way and a simple way for people to interact with crypto, great. So far, it hasn't happened. I can't tell you how many steps, because there's so many I don't remember when it comes to onboarding someone to VXV. We have what we call the VXV customer onboarding document, and that describes for a new customer how they can acquire BTC or ETH, and then how they can acquire VXV on IDEX. Now, there are about 30 steps. I could bring the document up now and show you, but there are so many steps, it's easy for a new person to make a mistake. So, yeah, I think maybe what would help adoption would be, every city should have multiple classes happening every evening related to cryptocurrency security and general software security, and getting people familiar with, the fact that we live in a technological society today, and they're gonna have to jump through some hoops, or they're going to get left behind.
And what's crazy about that is it really just circles back to a previous conversation on automation and the challenges we're going to face when a lot of the jobs are going to be outsourced, and it's going to require individuals to really pick up new technologies, learn new technologies, and kind of get with the times. So when we look at cryptocurrency or blockchain technologies, we're kind of facing that dilemma head on, and people do have the opportunity to learn about cryptocurrency, learn what it takes to get onboarded, amongst other things. And again, you're going to face certain skepticism. Of course, you've seen a lot of situations in which people don't really have the security-esque literacy to understand that they need to protect their computers, that they need to understand how security functions and within that environment to prevent their computers from being hacked, to prevent exchanges from being hacked, which in turn is going to put people off from investing in the technology. And it's a lot of it has to do with the awareness and visibility that we have to these technologies. Like you said, I think it'd be a great idea to provide individuals with classes to not only understand blockchain, but to also understand simple IT security, to understand how to protect your computer, to understand what the dangers are in relation to sharing information or to exposing your computers to these harmful viruses such as malware, amongst other things.
And let's just not forget social engineering. That's a big way that people can get hacked.
And it's one of the most simple ways people get hacked on that. It's more or less being able to convince people to give them your information in some manner. There's a lot of examples of social engineering occurring with the means of stealing someone's personal information or financial information. So, Kasian, it's been awesome talking to you. But to quickly close our conversation, since we're running low on time, what is something you would say that you're most excited about within artificial intelligence, machine learning, blockchain? What is something that stands out to you with the most potential or the most excitement?
Well, the most exciting thing would be what's happening with space biosciences. And that's the ability to protect humans during extended space flight, because that's the only way we're going to inhabit other planets. And if you can solve for LAT radiation damage repair against your DNA, you can solve for other kinds of diseases. So I really look forward to putting a lot of work into that, and I look forward to having our data sets be a big part of that kind of machine learning operation, that kind of AI operation, in terms of looking at data, finding patterns, and being able to solve for space travel.
Definitely fascinating insights by you. I really appreciate you taking the time today to sit down with me. That said, that will do it for the first episode of the All Things Interesting podcast.
Thanks for having me.